But my question also is, given this is an emerging capability need, do you see industry solutions emerging as best of breed those runtime harnesses, or do you see organizations still need to build their own harness models?
Yeah, it's fragmented. So going back 12 months when I started the AI architect role, there just wasn't a lot of these solutions. You had to roll your own, and they fit into a category of what I call boring problems. And so doing PRs is a boring problem. Doing agentic PRs now is becoming increasingly a solved problem because it's the clear next bottleneck after shipping, right? Is you're going to ship a large volume of code and it needs to be PR. And historically, those have been poor anyway, right? And we tend to, in engineering, rubber stamp stuff. Looks good to me, approve, which is a bad way to do PRs, but it's probably how a lot of PRs happen in most companies anyway. And so the agentic PRs, and there's some debate about how best to do this and should it be the same model as doing the invocation? And, whatever, we can debate that till the cows come home. But at the velocity that we're going to see code getting shipped, that's 100% is going to need to be agentic. And so in some slices of the SDLC, we're starting to see these tools emerge. And I think that's great. But companies are already starting to cry foul at the cost of tokens. These are just more token consuming machines, right? And so if we're not comfortable with the invocation tokens, we're probably not going to be comfortable with PR tokens, with the cyber tokens, with the QA tokens. And so I think we need to either get comfortable with the token spend, or figure out better ways to squash the cost of tokens, or get more comfortable using, open source models, and variable capable models. So throwing out some bits to say Haiku or Gemini 3.5 Flash for cheaper operations, rather than throw everything at Fable or hey. And that's typically, not handled that well in organizations. Everyone's throwing stuff out to supermodels as opposed to, figuring out these nice thin slices.
Yeah. Let's shift our focus on the SDLC, the software delivery lifecycle approaches emerging in AI engineering. And when we started AI-based coding, as we started with just asking AI models, ChatGPT or Codex or Claude to build a small feature, complete a small task, and what Andrew Kapathi at that time coined pipe coding, and that's the term that has stuck with us. But as we have matured the AI engineering practice, the shift has been around not just giving a task, but doing a proper spec-based development. Spec-driven development, so that the AI doesn't do the coding just by intuition, but it has a very clear view on what is the requirements, what is the inputs, and how it should test the outputs, etc. And now we are also showing the shift towards more goal-driven development, right? Which is, you don't necessarily go and intervene AI at every stage, but you design a very clear goal, and then let AI iterate towards achieving that goal. How do you see these shifts emerging? And particularly, I want to get your thoughts on, when we talk about spec-driven development, what best practices are evolved there, and how spec-driven development and goal-driven development, which is now being taught more nowadays, how they're going to complement with each other.
Yeah, sure. So I before it had a name, I was doing spec-driven development. My first use of AI for coding was the copy and paste, like a lot of people, right? You ask a question, basically using ChatGPT like Stack Overflow or something. It's spitting out an answer. You copy and paste that into your IDE and run. Obviously that was inefficient, and so companies like Cursor and Claude Code saw that single line complete, and kudos to GitHub Copilot. They were very early on this, and they were doing this single line completion, and that was great for what it was. Then the others thought, what if it could just complete more than one line? What if it could complete a whole file? What if it could reason over multiple files? And so Cursor and Claude Code come in and start to do that. And say do the copy and paste as well, larger chunks. Obviously, as you start to handle more or hand off more to the coding agent, it needs more context. And so, if you ask it, build me Spotify, it has a really great reference to go from. It understands what Spotify is. It understands the branding. You can probably go off and search it and find, the DOM and return you something that's pretty similar. In most cases, you're not going to be rebuilding Spotify. You're going to be building something particular to your organization, a feature that's particular to some functionality that exists in your software. And so its references are going to be, more limited. And so giving it, just like, a human needs to have some framework around what it's building. This is what spec-driven development obviously, gives it. And so, some people see spec-driven development as just the PRD, where it's, a definition of various pieces. And I find that a little bit loose nowadays. Whereas I like to use, in that context, I like to use, because I also like testing. I've been experimenting more and more with, say, Gherkin and Cucumber style practices, where you give it, smaller chunks, which ends up becoming tasks. But I also like to then go through and do an architectural piece and a solution design piece. And so I can get more granular in terms of the upfront steering of what's going to go into the coding agent. Now, and so when I would consider spec to be, really clearly defined, thing that's going to be built. So a product requirements document with some breakdown of the end state, usage requirements, and what be basically good product practice. And then and incorporate some early injection of QA practice using things like Cucumber and Gherkin style language, and then move into the architecture. And so I'll have a separate architectural document where I define, it might be I get the original architecture of a piece and then extend that, and that gives me some assurance that it's going to land near where I want it to land. And then a solution design doc, similar to what I do. And honestly, the models are very good at generating almost all of that as well. So your spec, generate lots of it, review it, and at least you have reviewed. Anyone who's been doing spec-driven development for a while knows that the practice ends up becoming, okay, I give this to Claude. Claude, does, and I always do, a phased delivery. So give me, I want this to be a phased delivery, multiple tasks per phase. And it will split out those phases into tasks and then quite happily tick through those tasks. What happened about 6 or 7 months ago, people started talking about loops, and, there's obviously the Ralph Wiggum loop and others, things like, Gastown, which automate, large portions of this process. GSD is another one. And so what they found was, or what engineers were finding was that the model would go through, or Claude would go through as an example, and build task 1, task 2, task 3. And it's like, are you ready for task 4? And so their next action was, yes, enter. And so their involvement in the development process and ended up becoming saying yes and hitting enter. And hopefully they had some other, skills and things in there, or something in their Claude MD or what have you, that was steering the agent to also build tests and other things. And so, their involvement became less and less the better the models became. And so then you start to go, well, why bother hitting yes, enter at all? Why wouldn't we just loop through that, and get, through full completion? Now, what I found with what I found with a lot of the sort of particularly the early loop tests, and now there's some more defined governance loops. Earlier models would hit about a 70% good outcome. Now we're getting to more like probably an 80 to 85% good outcome, and you still need to do a lot of rework and testing, but most of it I find now at the end of the loop or at the end of a goal is I'm educating myself on what was built and getting it to replay to me and prove to me that what I've built was good. But these, I've had loops run for just hours, whole days, and at the end of it, I'm poorer because the token costs, but B, have just a huge corpus of code that now I have to try and understand. But functionally, more and more, and particularly with models like Fable and GPT 5.6, I'm seeing that there's code that is just very good, or outcomes that are very good.